In this video, I want to get everyone started using Python. So what is Python? Well, I'm not going to say too much about that. I'm not really the right person to do that, and this isn't the course for it. Python is a programming language that is incredibly powerful. And if you are planning on taking more math courses in particular, if you plan on doing anything data science related, I highly recommend learning more about Python. For our purposes in Math 301, we will basically be using Python as a glorified calculator. So that is, instead of using a handheld calculator or using some sort of internet-based calculator that's really kind of only good for one thing, we'll use Python, which is good for lots of things, to do all of the calculations that we need to do by hand. With linear algebra, we often encounter these calculations that aren't actually that difficult to do, but they're tedious to do because they involve a lot of steps and a lot of small computations. And so it's a very natural place for using software. I should mention, for the most part, we will also be doing these calculations by hand. That is, we will need to know how to do calculations using pencil and paper and just basic scientific calculator operations. We want to know how to do both things. We want to know how to use software and how to do things by hand. The way I like to think of it is we want to use software because we want to, not because we have to. That is, we'll use the software to do a computation that we could have done by hand. It'll just be a lot quicker because software did it. So the goal of this video is to get you started in Python. I will not assume that you have any background knowledge of Python, nor do you need that for this course. That said, if you do have background knowledge of Python, if you've used it before, if you've used it a lot, you should feel free to run Python however you normally do it, whether you want to run it through the command line, whether you have an IDE that you like. That's totally fine. I'm going to introduce it in Google Collaboratory because that is a relatively easy place to get started using Python. So let me quickly switch screens. So Google Collaboratory is, some people pronounce it Colab or Collab. It's short for collaboration, so I usually say Collab. In any case, it's available through Google Drive, which is nice because your Boise State account already has Google Drive access. So to get a Colab notebook started, you're going to go into your Google Drive and you're going to click New. And you go down to More. Notice that I have Google Collaboratory as an option. You might not have that on your computer because you might not have already used this before. And so if you haven't, you have to go to Connect More Apps. If you don't see that line there, click on Connect More Apps, and you can search. As I start to type it in, I can search for Collaboratory, and notice I can see that it's installed on my Google Drive, and so there's no install button down here. But if it hadn't been, there would be a button there, and you would click right here, and then you would be able to create a document. So you'll need to do that first, potentially. But once you've done that, you can click New, click More, go to Google Collaboratory, and it will open a new document to get started. So in this document, we could type Python code and run it. And so I could, for instance, type print my name is Scott. And I'll click play here. It'll take a little while. And it printed my name is Scott. Now, this is always the kind of typical example, the hello world example that people start computer programming with, and it seems kind of useless, right? This isn't why we did this, but I just wanted to get you kind of, I guess, attuned to how Google Colab works. So I just did that. If I wanted to add more code, I could click plus code and I would have another spot, and I could then type, I don't know, print welcome to Math 301. And instead of clicking play, if you're just kind of typing, if I click Command Enter, or I think Control Enter, if you're on a PC, if you mouse over this, yeah, so either Command Enter or Control Enter will run the code in the block that you're working with. All right, so hopefully everyone has now opened up a Colab notebook. I want to show you some basic things we can do in Python that are math related. And so I have a notebook here. Anytime I show you these notebooks in these videos, these are available in the Canvas site of the course. And so you can either create your own notebook and kind of make stuff on your own to follow along, or you could go and make a copy of this notebook if you just wanted to run it. And that way you can take what I started with and modify things. So the first thing I want to do is show you just some really basic arithmetic in Python. And for the arithmetic we're doing, we don't need any special packages. We can just do the arithmetic. So if I want to add two numbers, 2 plus 5, the first computation always takes a little bit when you're running stuff in Colab. We get 7. If I want to multiply, I could do 7 times -4. Times is an asterisk. If I want to divide, I use the /. If I want to do exponents, let's scroll here. I use 2 asterisks. So 2 asterisk 5, that's hard to say, is 2 to the 5th. So I get 32. And I can use this to do roots, right? If I wanted to do a square root, for instance, the square root of 25, I could raise 25 to the 1/2 power, and I'll get 5. All right, so some really basic arithmetic operations. As things get more complicated, we need to use other packages. And so first I'm going to show you the NumPy package. So that's for numerical computation in Python. That's the num part, and the pi is Python. First, I need to import this package, and it's not important kind of exactly what this means if you haven't seen Python before, but what this is going to allow me to do is to use all of these things that already exist in NumPy to do calculations. So if I want to take a square root, np.square root would give me the answer. And notice we have this kind of weird output here that may not be what we want. And so sometimes you get an output that doesn't look great. It turns out there's often ways to fix that. So if instead of just typing that command, I tell Python to print that command, it will print out 5.0. All right, what else can we do? We can define things and use them in calculations. This will be really important when we're defining a big matrix and we want to use it over and over again. So for instance, if I wanted to add together the square root of 3 plus the square root of 5, here I could first define a to equal 3, b to equal 5, and then let c equal the square root of a plus the square root of b. And now this variable c exists to be used later. And so if I just quickly add something here, if I type, for instance, c squared, it uses this number c that we've already created in the previous block of code. I'm going to delete that. All right, so that's a basic introduction to things we can do using NumPy. And again, mostly we'll use this using matrices, but this is just some basic arithmetic with numbers. Sometimes we want to do symbolic calculations. For instance, if we're doing things with fractions, doing things with square roots, we often want exact answers and not decimal approximations. And to do that, we'll use SymPy. That's sim for symbolic and pi for Python. So first, I have to import SymPy. And now what I'm going to do in this next line is I'm going to define c to be 9/4 and d to be 5/6. And then I'm going to add them together. And notice what happened was, instead of giving me 37/12 as a decimal, it gave it to me as a fraction. Situationally, you might want this answer as a decimal, or you might want it as a fraction. If you want it as a fraction, SymPy is a better choice than NumPy. All right, so notice we already used square roots in NumPy. So if this is taking 2 over the square root of 2 in NumPy, and I get 1.4142. And notice if I do that in SymPy, the same calculation, it tells me that the answer is the square root of 2. And so this can be nice, right? Because 1.414 might not immediately jump out at you as the square root of 2, or maybe it did. But if you didn't notice that, the symbolic calculation makes it clear to you that this isn't just some decimal you've never seen before. This is, in fact, the square root of 2. Okay, so a few interesting things I just wanted to point out. Sometimes that trick of printing stuff can make stuff worse. So let me make sure we can see here. If I print the square root of 2, it gives me the answer as square root 2 instead of drawing the symbol, which is kind of interesting. All right, but let's say I'm working in SymPy. I have this variable f that's the square root of 2, and I want it as a decimal. I can convert it to a decimal using this .n command. The n is for numeric, I believe. What else can we do? Well, just kind of running through some things. The number pi exists in SymPy, right? The number pi also exists in NumPy. We could take the cosine of pi over 4 and get an exact answer. And just finally to point out, we should be careful of going back and forth between SymPy and NumPy. So notice this variable pi I defined up here was a SymPy object. So it's a symbolic object. Now, if I try to take a cosine using NumPy, I get a weird error message because NumPy is not really designed to interact with SymPy. So if I wanted to take the cosine of pi over 4 in NumPy, I would want to actually run code to do that in NumPy. All right, so that was a really fast run through of a bunch of computations using SymPy and NumPy. But again, play around, if you're new to this, play around with this notebook on your own, try some things, try to get used to some of these little nuances. We are going to use SymPy and NumPy for much more complicated computations where we actually need Python, right? You may have been watching this video saying, like, what's the point of this? It's important to try things out where you know what the answer should be, right? So if we're getting used to how things work with SymPy and NumPy, when I took this cosine of pi over 4, I knew that the answer was root 2 over 2, right? I know that the decimal expansion of pi is 3.1415. And so I think it is important, especially if you're new to Python, go through this sheet, change a few things on your own, kind of get a feel for how things work. Because once we start working with matrices, we're really going to be often relying on the software to give us answers because we don't know what the answer is. And so we want to trust that we understand how to use it so that we don't have to assess whether those answers are right because we won't know whether they are. All right, so hopefully that was useful. Hopefully that gets you started into Python if it's new to you, or if you've seen it before, got you restarted with Python. Yeah, so in future videos using Google Colab, we'll start to see how can we take calculations from linear algebra that are computationally hard to do by hand because they take too long. How can we take them and quickly do them using software?